The Argentine Road Association, and as the committee of the PIARC, is organizing this international committee for use of recycled materials in paving. During the 3 days that we are going to have in this meeting, we are going to have different experiences presented about the reuse of materials for recycled pavements, and we're going to deal with case studies from different parts of the world on this topic. Good morning, everyone. The Argentine Road Association, as the National Committee of PIARC, welcomes you to the organization of this international seminar on use of recycled materials in paving, corresponding to Technical Committee 4.1. And during the 3 days of this meeting, we are going to have more than 18 specialists from around the world presenting different experiences about the use of pavement materials that are recycled, with case studies from the whole world. For this opening session, we have Nicolás Vaz, the president of the Argentine Road Association, Emma Abreu, the executive management manager from Vialidad Nacional, the president of the Committee 4.1, and other authorities. Now we're going to hear Nicolás Vaz, the president of the Argentine Road Association. Good morning. Today we're opening the International Seminar of Technical Committee 4.1 of PIARC, the World Road Association, organized by the Argentinian Road Association as the Committee for Use of Recycled Material in Pavements. From our association, we know that this is the road that we need to follow, generating seminars and events of this type, bringing new technologies, innovation, and knowledge transfer. This is one more contribution from the association for the whole road industry, working on innovation for advances in transport, safety, and communication, because that is the way to make progress as a whole, as a community. No doubt, this is an opportunity for professionals from Argentina and different countries around the world to have training with access to new technologies and the last trends in the world. We understand this is the way to promote training, investigation, research, development, and communication to increase the intellectual and social culture related to roads. Despite the pandemic that is not allowing us to do this face-to-face, we believe that this is a very good meeting point because we have more than 1,400 people exchanging ideas for the road and transportation industry. We are going to take advantage of this seminar because it's a great opportunity for training in the field of recycled materials and their use in roads. I want to thank the specialists who are excellent, and they're going to do presentations in these 3 days for this seminar. And I want to also thank all the participants that are going to follow the event along these 3 days, together with the World Road Association that accompanied us in the organization of this meeting. We also want to thank the Argentine Road Association. So on my behalf and the Argentine Road Association, thank you very much. Thank you very much, Mr. Nicolás Vaz. Now we're going to invite Emma Abreu. Welcome, everybody. It's a pleasure for us as the National Road Administration to welcome you to this seminar for the use of recycled materials in pavements. I'm very happy because this has allowed us from Argentina to be present again with the PIARC. There was a time in the last administration where we were a little taking a back seat, but now I said I'm very happy because the Road Association in Argentina is convinced that continuous training of professionals makes progress in the knowledge for our country. This seminar that the Argentine Road Association, together with PIARC, is organizing brings the participation of different specialists from Europe, Spain, Italy, France, Switzerland, and Norway, and also South Africa, the United States, and Latin America, with colleagues from Brazil, Uruguay, and our colleagues from Argentina, will enable this exchange of information and knowledge, which we are sure it's going to be really important for our roads. In the last 4 years, the technical specifications have been updated for pavements, and in 2017 we had incorporated specifications that had to do with the use of recycled material and dense mixes. And we included in the northeast of Argentina the use of rubber in pavements and hot mixes, but this is urban works that have to do also with hydraulic works, and that's why the rubber pavement is not in place yet, but we are sure that all of this is going to improve with the use of these new technologies. In this seminar, it's very important to have participation. We have more than 1,500 people enrolled, and we have 300 people working in the organization of this seminar. So we want to invite all of you for this training so as to use the knowledge. And also the first delegate of Argentina in PIARC, we want to welcome you, and we hope this is going to be a very productive seminar with the participation of all of the professionals. And so I want to greet everybody and welcome everybody. Thank you very much. Thank you, Emma. Now it's time to hear Patrick Malechark, the General Secretary of PIARC.
But I see that you have a feature to call for simultaneous translation at the bottom right of your screen. So I hope it works properly for everyone. It's my great pleasure to be here. There's more than 1,600 registered participants in this Congress today, in this seminar today. And I would like, before even starting my few words, by thanking the Asociación Argentina de Carreteras, the Ministry, and our colleagues from the organizing committee, Federico Andreon, and also our committee on pavements, Margot Brissing, who have done a really good job together with our team here at the General Secretariat, Miguel Caso Flores and others, in making sure that this seminar happens properly. So you are all familiar with PIARC, and thank you very much, Emma, for your very kind words. We were founded more than 110 years ago to organize seminars and congresses like today, because our goal is to organize exchange of knowledge on everything that is related to roads and road transport. We have 125 member governments. There are main members as well as regions, companies, etc. And the way we work is thanks to people like you in the committees and people who are experts, who are willing to share their points of view in committees. And we are very happy currently to have more than 1,200 experts from all over the world in 20 committees. This is the sort of things we do: a newsletter, a detailed website with lots of reports, webinars, a magazine, and other conferences. So what we do is roads, and Margot will tell you much more about pavements. In our plan of activities, we really intend, and we do, reflect trends that affect society as a whole. Climate change, resilience, and we have events all over the world that show that weather events are becoming much more serious, road safety and innovation. And use of recycled materials in pavements is a very relevant topic for everyone across the world. All these issues will remain, but as has been mentioned earlier by Nicolás, the COVID crisis has brought changes. Before COVID, we had to answer lots of societal expectations. Roads need to reduce the carbon footprint. We need to help fight extreme poverty. We, of course, as usual, improve access to schools or to hospitals for all, and all while maintaining good road safety levels. We cannot change those ambitions, even if we need to prioritize sanitary concerns in transport. So we need to combine all these aims. And for that, there's one way that we can help at PIARC and with Asociación Argentina de Carreteras is through information sharing, so that you can learn in Argentina what we are doing in many other countries, and vice versa. We can learn what you are doing in Argentina and learn from your ideas and your best practice. So to do that, we organize events and congresses. The next big congress that we organize will be in February next year. It will be about resilience as well as winter service. We also organize lots of thematic seminars, and you can see on the screen with Ukraine, with Russia, with Romania, and the one today. And we have two very important conferences, and I guess the first one will be very important for you. The 9th SURF Conference, SURF 2022, which will take place in Italy, in Milano, in September 2022, 1 year from now, and hopefully face-to-face. So Argentina and PIARC, we have a very long history. Argentina was one of the very first countries to join the association in 1911. We have a vice president of the association who is from Argentina, and we have several key people who are secretaries of our committees, Lodi, Mariano Barone, and Daniel Russomano, of course, and many experts from your country. So thank you very much from the bottom of my heart for your involvement in the activities, and I hope that in Argentina you find that really useful. And I will remember the executive committee meeting that we organized in 2019, that you organized in Argentina, in Buenos Aires in 2019. Really good memories for everyone. So there's a long history of successful PIARC events in Argentina, and today the seminar will be another example. So thank you very much for the effort, for the support, and I wish everyone a great conference. Dear delegates, dear organizing committee, dear Pavements committee, and good luck as well. Thank you.
Muchas gracias, Patrick Mallejac, por tus palabras. Por último, para cerrar.
Thank you very much, Patrick Mallejac, for your words. And to close this opening session, we are going to listen to Marco Briac from the National Road Association.
I hope you should see my presentation now. So, good morning, Argentina, and good afternoon from Brussels in Europe. I'm the chair of the Technical Committee 4.1, which is dealing with pavements. And I will be, let's say, the bridge to the more technical part of this seminar for the next 3 days. So I would like to take a couple of minutes to introduce the TC to you and talk a little bit about what we are doing in our technical committee and the different subjects we are working on. So here you see the list of all the tasks which have been attributed to us by the PIARC community. So the first one is the use of recycled materials in pavements, which of course will be the main subject of this seminar. And yeah, since it's the main part of this seminar, I will return a little bit later with a bit more details what has been done and what is still going on. Nevertheless, I will go back to a few other tasks. So the next one is about innovative pavement maintenance and repair strategies. There we are going to collect different case studies also from all over the world regarding pavement maintenance. It's a work which has started quite recently at the end of the beginning of this year. Normally, it should be finished somewhere in the middle of next year. The next one is about resilience. Patrick already mentioned it shortly. Resilience is the main theme of the whole strategic team 4. Strategic team 4 is about resilient infrastructure. And in my TC about pavements, we are looking at measures to improve resilience. Yeah, Patrick also mentioned already the Calgary Congress. Of course, you're all invited there. It's also will also be online. It's not only about winter service, but also about resilience. And there, the TC will have 3 sessions about pavement resilience. So there we will share some of our case studies from the TC and 2 more sessions about presentations of papers which we have received, and we have received quite a lot. We have received over 30 papers regarding pavement resilience. Some of those will be presented at the Calgary Congress in February next year. Then road monitoring is also a theme which returns each cycle in the pavements committee. So the last 2 cycles we published 2 reports on road monitoring, which addressed the more, let's say, the traditional way of monitoring pavements. And this cycle we are going to focus more on big data. Big data, of course, is a hot topic in the road community, where we're looking at how can we use the big data coming from sensors in cars or from sensors in smartphones, and how can we use them to monitor roads. So we're writing a literature review about it, looking at the different research that's going on, different applications that have been developed using these kinds of big data. And here I want to mention 2 conferences. The first one is not really a PIARC conference, but it's the International Conference on Managing Pavement Assets. This should have taken place 2 years ago, which of course didn't happen. But hopefully next year, so with 2 years delay, it will take place in Chicago as a face-to-face conference on asset management. So there we will join the TC 3.3. That's a Technical Committee on Asset Management, and together, so pavements and asset management together, we will host a PIARC session about the use of big data in asset management systems. So you're all invited there, of course, but you have to travel to Chicago for it. And the last one, or the second one, also next year, it will be in September next year. It's our, it is a PIARC event. It's the Symposium on Surface Characteristics, or SURF for short. It's a symposium which takes place every 4 years. The last one was in Brisbane, in Australia, in 2018. The next one will be in Milano. Of course, it's a much broader topic than big data, but it's mostly about surface characteristics and monitoring pavement condition, and big data can be a part of that as well. So I also would like to invite you all to Milano next year in September. So and then finally, there's still a short task about carbon footprint. Last cycle or the previous cycle, we published a report on carbon footprint. And this cycle, we are making a summary of it. So it's easier and faster to read. That will be published very soon as well. So back to the top, use of recycled materials in pavements. There we have 2 tasks, a literature review and collection of case studies. And I would like to spend a couple of minutes on those. So the first is the literature review. This is already been finished. You see the cover at the right of the screen. So the English version and also the Spanish version are already available. So you can download them from the PIARC website. So the literature review covers all the different aspects of pavement recycling. We split it up in 2 big groups. So after an introduction chapter, what you see at the left, so we've got 7 chapters. And then we have 2 groups of chapters. One is about recycling in place, where you use the pavement which you find on the road and recycle it and mix it with a binder on site. And the mixing is done with 2 binders. And so we have a chapter about hydraulic binders, another chapter with using bituminous binder. Now, since the investigation for in-place recycling is always very important, so that you know about the quality of the existing pavement and the existing pavement materials you could recycle, we've added an extra general chapter about the preliminary investigation for the in-place recycling. Then the last three chapters are about mixes, pavement mixes, which are made in a plant. Here we're looking at the applications, and so we're looking at the recycling or the reuse in asphalt pavements, and recycling of concrete pavements, and recycling in base layers. So these are the six main chapters of that literature review. And as I said, you can already download it from the PIARC website. The next one, and that one is almost finished, is a collection of case studies, which literally come from all over the world. Of course, there's, as usual, quite a big amount from Europe, but also from North and South America, from Africa, Asia, and Australia. So in the end, we have 33 case studies that we have collected. It's not yet published. We're at the moment in the review stage of this document. But normally, the coming weeks, we should be able to send it to PIARC General Secretariat for approval and publication. So then you can download it as well and read it. But you will already get, let's say, a sneak preview, because several of the case studies which are published there, you will hear them presented today and tomorrow and the day after. So here we have the same layout, let's say. We have, again, the different chapters about in-place recycling and in-plant recycling, again, with using either hydraulic binders or bituminous binders. In the right-hand column, you see the number of case studies for each chapter. It's probably not surprising that asphalt pavement is at the top, because it's, of course, a material which has been used for several decades now. So there's a lot of information there about reusing reclaimed asphalt pavement in asphalt layers. So there's also at the bottom a general chapter with 3 case studies. So, and in that chapter, you will find some of the cases which don't really fit into those other chapters. So in total, 33 case studies, which you can read in the collection after it has been published. So that's what I wanted to say to you today. I would like to wish you, of course, a very fruitful seminar with the picture of our TC from the first and up to now only face-to-face meeting we had at the kickoff meeting in Paris. So I hope you have a fruitful seminar, very inspiring ideas, and hopefully lots of discussion between the TC members and the local speakers about the use of recycled materials in pavements. Thank you.
Muchas gracias.
Thank you very much, Marko Priesnik. And with this, we close the opening session. We would like to thank all the participants, and we will invite you to stay connected. We are going to have a brief space for technical connections, and then we will start with all the panels and the sessions of this seminar. Thank you very much.
Sí, ¿qué tal? Buenos días. Todo bien, todo muy bien.
Hi, everyone. I think I will leave you here. So thanks again for the invitation. I wish you a great Don't hesitate and send me a message by email or anything if it's needed, right? And Jesus, I hope you enjoy your vacation after that. Thank you, Margot. Bye-bye. Bye, everyone.
Bye.
Goodbye.
Au revoir.
Bueno,
Hola,
gracias.
buenos días.
Buenos días.
Lo voy a
Raúl,
pasar
pasa-
yo al PowerPoint, pero vamos a hablar los dos. Ok. No sé si se escucha.
Hola, 1, 2, 3, probando el inglés. Micrófono de la derecha.
No sé si me escuchan bien a mí.
También.
Muy bien.
Ok.
Gustavo, aprovecho y te hago una pregunta menor. ¿Se pronuncia Gustavo
Bolla, italiano.
Bolla? Okay.
Hola.
Bueno,
¿Hace inglés? 1, 2, 3, 1, 2, 3, probando. 1, 2, 3, 1, 2, 3, probando.
Buenas tardes.
Buenas tardes. Diego, directamente pongo a compartir mi pantalla.
creo que sí, te pidieron que la compartas, ¿no?
Sí, pero no sé si me dices cuándo.
No manejo la técnica, la está manejando Federico, pero creo que ya podrías compartir. Espera, a ver si Federico nos
Bueno.
indica. Federico, comparte pantalla, Raúl.
¿Ahí lo ven bien?
Perfecto.
Bueno, como suele ocurrir, las filminas no pasan. Ahora un segundo. Es típico esto. Es decir, ya va a pasar. Ahora me parece que sí. Bueno.
Vale.
Sí, espera todavía porque también está trabado acá el PowerPoint. Ya vamos a solucionar eso también. Bueno, parece que funciona.
Margot dice que dejó el Zoom y que está en la plataforma del web para seguir el seminario.
Muy bien.
¿Qué ocurre? Que
¿Tenés trabado el Power?
sí, es que recién pasaba y ahora dejó de pasar de nuevo. Y, bueno, un segundo. Voy a dejar de compartir un segundo.
Federico. Bueno. ¿Hay alguna instrucción después para Jesús, para cuando termina, porque inmediatamente termina Raúl, tiene que compartir la presentación de él, ¿no? Sí, hay un tiempo porque lo presento, digamos, ¿no? Pero bueno. Bien. ¿Querés hacer una prueba, Jesús? O...
Bueno, pero lo que pasa es que tiene que dejar de compartir. ¿Comparto pantalla?
Ya dejo de compartir yo, así pues estas dos. Ahí está, listo.
¿Se ve?
Sí.
Perfecto.
Ok.
Ahí igual no está en modo presentación, ¿no?
No, todavía no lo he puesto. Era saber si se veía mi...
Bueno, buenos días a todos. Muchas gracias por conectarse. Vamos a dar comienzo a esta primera sesión del seminario. En este primer módulo tendremos 2 conferencias técnicas y luego de estas conferencias abriremos un espacio de intervalo para debate y consulta. Les pido a todos ellos que quieren realizar una consulta que utilicen la ventana que encuentran abajo a la derecha para escribir la pregunta que nos va a llegar por el sistema. Les pido que eviten utilizar el chat para agregar ahí las preguntas. Para esta primera conferencia que vamos a tener en esta primera sesión, nos acompañan los ingenieros Raúl López y Gustavo Bolla, que nos van a presentar reciclado de pavimentos asfálticos estabilizados con cemento Portland normal y ligantes hidráulicos viales. El ingeniero Raúl López es ingeniero civil, especialista en tecnología del hormigón y del cemento. Actualmente es el gerente del Centro de Desarrollo e Innovación de Holcim Argentina y es profesor en tecnología de los materiales de la construcción en la Universidad Nacional de Córdoba. Gustavo Bolla, por su parte, es ingeniero civil con un magíster en mecánica de suelos y en ingeniería vial. Actualmente es gerente de ingeniería de la constructora Dos Arroyos y también es profesor e investigador en la Universidad Tecnológica Nacional en Argentina. Bueno, Gustavo, Raúl, pueden comenzar la presentación cuando gusten.
Muchas gracias, Diego, por la presentación. Adelante, Gustavo.
Bueno, buenos días. Presentaremos el estudio de mezclas recicladas en pavimentos asfálticos, estabilizadas in situ con cemento Portland normal y ligantes hidráulicos viales. Presentaremos la evaluación para un caso real del comportamiento de diferentes agentes estabilizantes cementicios incorporados en distintos porcentajes a una mezcla reciclada de un pavimento fresco. Se analizará el efecto de las variaciones granulométricas de las mezclas.
We will analyze the effect of different granulometric mix, the effect produced and the delay in the compacting and resistance and resilience and density. We will finally present the evaluation on the effect produced on the structural capacity by applying this rehabilitation method in a stretch of a road in the province of Entre Rios with a binder specifically created for this job. In place, recycling is an alternative for the reconstruction of our roads with great deterioration. In general, we use self-propelled machines that can recycle pavements and deteriorated bases up to 40 centimeters. It is an environmentally friendly technique with the reuse of existing materials, and what we try to do is to minimize waste generation. We can also add to the resulting mixes different stabilizing agents such as cement or asphalt emulsion. So we have, in this case, used Portland cement or specific hydraulic binders. Which are the opportunities to recycle? It is important to recycle when the structural capacity of the pavement is not adequate for the current and future traffic, and when it is necessary to do a quick recovery or reclaiming of the use of the road, and when the existing pavement condition requires deep patching over 15 to 20% of the surface. So it's a profitable technique. So this is the in-place recycling technique. We put the material in the front of the machine with recycling drums and wetness moisturing within the recycling. We have water tanks that go at the front of the machine, and then we can also use a technique by which instead of moisturizing, we use cement slurry within the drum, in the roll, and we place the mix there, directed to be distributed and compacted at the back of the machine. So factors affecting design and construction, some of them are the immediate commissioning of the rehabilitated area. If that's not possible to use alternative roads, sometimes there's no possibility to use any other alternative roads. Another factor is the need to have a quick recovery of the structural capacity in terms of the structural number required by the road, and also mitigate the environmental impact by minimizing the generation of noise, dust, or waste when working in urban and semi-urban areas. As to the reconstruction process, what is important is the rational use of materials and available equipment. This rational use will condition the granulometric optimization. This means that we must design thickness and eventual granulometric correctors with new materials. This is not advisable from the economic or environmental point of view. Then we need to choose the binder. And finally, we need to choose which is going to be the recycling and compacting machine or equipment. So what we are going to present here is some of the lab studies that were used for this case study. First of all, we show in this table to the left, in the first column, you have the existing structure and the actual pavement. And it had an asphalt overlaid over a black base, then calcareous base, a calcareous subbase. This was a base of selected soils, and finally we had the common soil subgrade. To the right, we can see some of the situations found there. And we did a study to assess the depth to be recycled, and the recycled depth was 30 centimeters and included the asphalt base, the black base, and the calcareous base. And why did we choose that depth? And this was related with what Engineer Bolla said about granulometric use. If you can see to the right, you would see in the line, in the full lines, you could see the granulometric limits that were set in the projects. And in the red line, you are going to see that the granulometric curve obtained by recycling the asphalt layer with a coarse material here. And if we recycled not just the RIP, the wrap, but also the base, we were able to come into the limits of the request for proposal. So beyond that, the result obtained in each of the cases were significantly different. On the graph to the bottom left, we could see resilience at 7 days obtained with the two granulometric settings, changing the percentages. Here we have the first test with normal Portland cement, and if we could not meet the granulometric parameters, we could see even with high cement percentage, we could not get to those numbers. Once we selected the granulometric setting, we decided to work on the one hand by using normal Portland cement according to the Argentine cement standard, which is ERAM 50,000. And the other options were road hydraulic binders that were tailor-made to be used with the RIP, with the reclaimed pavement. And these components are regulated by the European standard 13282, parts 1 and 2. In this case, we used two road binders that had the same raw materials but in different proportions in order to obtain different behaviors. Binders used in this job are formulated as from active hydraulic components, and they will cement the recycled mix. And the properties we are looking for here, compared to a cement, is to reduce the initial reactivity in order to obtain longer available working times to develop long-term resistance or strength, and having a good volumetric stability. And something that is important nowadays is that in fact they have a lower carbon footprint compared to cement. Among the studies that were conducted here, we can see two graphs with one of the binders, S2, and the Portland cement, and we studied the strength of the different components with different binder percentages. In this graph, we have strengths at different levels with the binders. We have the black line, which is at 7 days, the blue at 28, and the red at 56 days, both for cement and the binder. One of the things that we saw is that with low percentages of cement or binders, we cannot obtain appropriate or adequate resilience or strength, and this is related to the lack of homogeneity on the mixes. At the other end, when we have very high percentages, it was not very efficient because the curves would flatten specifically at 56 days, so a higher percentage of binders would not bring about important benefits. And some of the things that we saw in these graphs, it's important evolution between 17 and 28 days, and then not much increase between 28 and 56. With binders, what we are looking is to have a more uniform or standard evolution of this strength. And we can see that with the cement, we were able to obtain higher resilience or strength compared to the binder. But we need to have a caveat here. All these tests were done by compacting the mixes immediately after mixing the stabilizing agent with the recycled material. So what we did afterwards was to study the variation of properties based on the delay in compacting. In this graph, we can see how density changed relatively compared to the delay in the compacting for the three binding stabilizing agents used. So if we took 3 hours, at 3 hours, we saw that in terms of density, with cement, we lost between 8 and 9% of density, and with the binders, just 1 to 3%. Another analysis conducted was considering the open time definition. That means that is the time you have available for working, while the drop in density is just 2%. It means to go from 100% to 98% of density. So with cement, we had an open time of only 30 minutes. And with the binders, we can get up to 2 or 4 hours, depending on the composition of the material. So this was also seen later on in terms of strength. Up at 4% of binder, we could see the variation at 7 days in terms of the delay in compacting. With the cement, we were able to have very high initial resistance or strength, much higher than with the binders, but as we delayed compacting, the binder was showing better results than cement. On the right, we see exactly the same, but in percentage terms, the variation of resistance of strength compared with delay and no delay. And at 3 hours, we can see that with S2 binder, there was no drop in strength, and with S3, there was a 10% variation, and with cement, strength had dropped a little bit over 30%. But we also were able to see that as we increased the percentage of binder, this percentage drop in strength were higher. So in order then to define the type and percentage of binder to be used in stabilization, it is convenient to do lab tests by simulating the estimated delays in the work between the mix of the materials and compacting. Gustavo? So finally, we will present a field study done in the province of Entre Rios in the provincial route number 6. It's a stretch of 3 kilometers between and in the route in the province of Entre Rios. We use PIARC WR 2500 equipment, and we use 3 passes to complete the job. And we recycled 30 centimeters of thickness, and the stabilization with S2 binder. We projected compression strengths, minimum compression strengths at 7 days of 2.0 MPa by using an S3 binder of 3.5% in dry mix weight, compacted at maximum density. Here we don't have the possibility of having alternative roads, so we commissioned the road once again at 24 hours, just all doing irrigation. We did priming with EM1 emulsion, reinforced with crushing sand. Then at 9 months, we did a 5 centimeter layer. At 13, a second 5 centimeters layer, and at 40 months, we conducted the first reinforcements and with another 5 centimeters layer overlay, and at 6 years, a 5 centimeters asphalt overlay. This alternative was defined taking into account the economic conditions at the time. So here we can see the evolution of these works. Originally, it had very low curves and high deflections, as we can see in point 1. This was the time before the reconstructions of the recycled base. Point 2 is once we recycle the base, and we can see a quick recovery of the structural capacity of the road with a great increase of the curved radius and reducing deflections to reasonable values. Then, considering the AIDT that you can see there on the light blue line, that was consistent between 1,200 and 1,400 vehicles, we can see that as we reinforced the road, the structural capacity of the road just stayed quite good. Then, next. Finally, some conclusions. Cold recycled with hydraulic binders enables for a quick and economical recovery of the structural capacity. Some delays in compacting would affect the final quality, but may be counteracted with the use of a specific binder use and the adequate proportions. Granulometry of the material, it's a key factor for the final result. The quantity and type of binder may not be enough to reach the strength of the projects, and the selection of the binder and the dosage of the binder may enable us to have a greater control of the reflection cracks. We had had that occurrence with the use of the proper binder. Thank you very much for your attention.
Dejamos de compartir la pantalla.
Okay, very good. Thank you, Raúl and Gustavo, for this presentation. And now we're going to give the floor to our second lecture in this block by Dr. Jesús Díaz Minguela, who's going to present recycling with cement in the city of Castilla y León. Jesús is an engineer in roads, channels, and ports. He is a technical aide in the Institute of Cement in Spain, and he also presides the Committee for Communications regarding roads. And so, Jesús, now you have the floor. Thank you, Diego. I think that this technology is going to be very frequent when we talk about recycling. It's going to become the norm now. Can you see my screen and can you hear me? Yes. Good. Thank you. So this is not a new idea. In 1962, there was a publication about this, and this was being done in Spain, and before that in other European countries. And it's not a new technology. There's a difference in Spain between recycling, stabilizing, and on-site techniques. Recycling has to do with a rehabilitation or reclaiming technique using a homogeneous structure, and the road itself is used as a quarry. We may incorporate a conglomerate or a binder, and each layer is new. Sorry. And then on-site treatment is a base layer which is not firm, and there's a pavement where we are introducing a new technology with this new equipment, and it's based to sustainability, and we can differentiate between on-site or in place, which is used in a current road. Stabilization is existing soil, and the on-site technique is with a base layer. You have to take into account homogeneity, for example, the emulsion. This depends on the thickness of the layer. In recycling, you go to 10 or 12 centimeters, and the other techniques enable you to go to 20 centimeters. It is not done more because of problems with the base. And regarding cracks and breaks, there's a need to deal with water, and this translates into more durability. But these are environmental advantages because the quarry is the road itself. There's no transportation, so there's fewer emissions and fewer collateral impacts to other roads. It's additions, it's a cold technique, there's little emissions, and it has economical advantages. It's regarding cost because there's no transportation costs and there's high yield. It's better for cost-benefit effects because there's no need for a plant. Now I'm going to skip this part because this has to do with an analysis that I conducted for Spain, where I highlight the ratio between resistance in the long term. There's also a question that has to do with density and fatigue. It's 1 minus 0.058. And here you have the French standard. Recycled has been studied in the University of Burgos in Spain. And the resistance between, or the resilience for the short term is what you measure when you're doing the work, and the long term is measured when you control all the calculations. And this leads to this doctoral thesis, which shows a model of behavior and response, giving you the next calculation. It's for 7 days more than 2.5 MPAs, and for other recycling, it's more than 3 MPAs. And when you mix CNL, this is published in the norm with recycled bituminous mix, and it gets to 35 centimeters. There's only one change. In my calculations, instead of 12, I used 10.30. And really, you cannot touch this layer when you're recycling. There are two that I want to highlight when I talk about workability. The 1.3.28.6.45, 1M, which is for Europe and Spain, and this, the one that it's IPI or immediate variant index. I was getting confused with the name, but it's this index that I take into account for these two tests. The norm 86/45, where we take into account the quantity of material, which adds 2 points of density, and then you can calculate the time in minutes. You can see the graph with the test where we measured this test. And then when you open it to the traffic, based on UNE 1328.6.47, the IP is more than 50. Execution and preparation of the road, that does not admit on-site stabilization. It only admits this for stabilization but not for recycling. Then extension of the binder, it could be dry or wet. If it is dry, it's dust, and if it is wet, it's the virgin equipment. And in Spain, we have around 21, if I'm not mistaken, plus 5. It's UVR 2500, although I know that the 240 was used in some countries in Latin America. You have the caterpillars and the Racco equipment that are used for stabilization, but in recycling you use these 25 pieces of equipment that I mentioned. Mixing, joints, refining, compactation, curing. Here you have pictures of each of these. Refining, for example, here. Refining and compacting, and then curing. You have to be careful to use water at the right time, because the main problem here is that when you cure with water, with the bitumen truck, with the emulsion, the one that you use here normally comes later, after recycling. That is done, for example, at noon and at the end of the afternoon. So if it is necessary, to open it to traffic, you have to extend this. If not, you need to introduce a detour before you leave it some time before you open it to the traffic. I think that you have to be very careful in densifying, curing, and binding the layers. You have to be careful there. You have to be careful about cleaning. And this is a recycling where you need to be careful in execution, particularly, and especially because there are changes. This used to be a straight stretch, but now the existing layer differs from the previous one, and it modifies at the curves. You need to be careful about homogeneity versus heterogeneity. Here we show the dispersion process of heterogeneity in the results. And here, what I want to show is the connection between the foreman at the work, who's in charge of the work in Spain. They need to do many things, so it's not the right person to trust and give the results. For example, regarding density, you have to talk to someone on site to tell them that they need to get the information and modify compacting. Applications, well, it could be for railroads, harbors, airports, wind parks. These roads, for example, you see a park where in Spain we are used to stabilizing everything. Wind fields, and this park, we didn't know how much cement we needed to use, but we needed something to protect the legs of dogs in the park, but be able to provide protection for dog waste. In Castilla y León, this is an autonomous committee that has been doing this since 1999, and there's light traffic where you have 4 centimeters of bituminous mix and then rocks or stone. Sometimes it's 3 centimeters instead of 5. there's a wide variation, but there's 4 centimeters of bituminous mix and 30 centimeters of cement recycling. There's no granulometric correction, and there are variations between 32.5 for CEM IV. There are different types of cement in Spain, which is almost 200 types. So you need to choose the most adequate cement for each use, depending on whether it is a wind park, a road, or other uses. So you need to study ergonometric, plasticity studies, the optimum parameters are variable, and then you define resistance. It can be WM400 or the leveling machines, the rolls in a tandem for compacting. And this is what you see in Valencia, because you have a plateau. Then it's cured with water, and it can be open to the traffic immediately. The behavior has been great in general for more than 22 years. Here you can see pictures on a rainy day even. And then another recycling in the highway A231 in León, Burgos. It's 55 kilometers that were recycled and 26 kilometers with cement on site. This is one 3-meter wide that were recycled with 4 centimeters of BBTM for the whole layer, 12 centimeters of bituminous mix, and 31 centimeters of recycled on site with cement, 25 SC plus 6 MB. There were 25 centimeters plus 6 of bituminous mix, as I said, and the granulometric corrector was not used. In the previous study, I talked to you about ergonometric, and the modified aspect is resistance or strength. And here you have the equipment, the Virgin WM1000 and the 2500 for recycling, the leveling machine, and rolls with a ruler. And it's interesting to do curing with emulsion ECR1, and it was open to the traffic in 5 days with a very good behavior. You have recycling stretches here in the highway. This is used for recovery of the soil when there's failure. Here you can see the sequences and the photos showing the recycling with the equipment. This is the Virgin 2500, the VM, the WM Winkelmann, and here you can see the one with tires. There was a one with rollers before, and the curing emulsion. So this is here you can see the end product or the end result. Let me talk about a few conclusion works. There's a phrase from Seneca who said, sometimes we don't dare do things because they look different, but in fact it is more difficult when we don't dare do them. Einstein said, if you look for different results, you cannot do the same all the time. And then Quixote said, no science, if it is a science, can be, if it is a science, cannot deceive us. Then you have to take into account draining and the contractors. Sometimes the contractors do things that you're not expecting. If you go to www.ieca.s, you are going to find more information about recycling and many other technical guidelines. Thank you very much, and that's it for my presentation. I hope I did okay with time and gave you some information about recycling, so I give the floor back to you guys.
Muchas gracias, Jesús.
Thank you very much, Jesus, for your presentation. And so now I will also call Gustavo and Raúl to have our Q&A session. So the questions that I have received so far are those, of course, about the first presentation. Let's try to summarize them since we have received many questions.
The
first question is what type of material, in what type of materials have you used this stabilizing technique with S1 and S2 binders? Can you repeat, please, the question? What type of materials have you used with S1 and S2 binders? And what type of materials, what other types? But just thinking, in fact, in these cases, it was not S1 and S2, but S2 and S3. We have used them in some soils, not just for recycling, but also in certain types of soils with moderate plasticity, given the composition of these binders. They were not thought for greatly plastic soils, but for H2, A4, A6, or some sandy soils, those could be adequately stabilized with these binders. And also, I take the opportunity to ask you, Raúl, the second question is, have you done durability tests? Have you conducted? Yes, we have done durability tests, but what we are trying to push for is that durability test used here in Argentina, which is more wetness and dryness and freezing and melting. We do them, but at 28 days, because these binders take a little longer as regards to strength evolution. And what we are trying to implement, but this is quite recent, that was not in place when we did this work with Gustavo. It's something related to the French standard. I don't know if the same happens in Spain. It has to do with the relative strength of the material after being soaked in water for a prolonged period of time. We are also implementing this type of tests to measure the durability of the material. Let's go to Gustavo now. Two questions. First, what was the year this test was conducted? And then, based on your experience with this, the estimated medium time as regards the delay in compacting, and what's the most frequent causes for this delay? This experience took place at the beginning of 2000. We started approximately 2001, 2002. It was, as you saw, there were many reinforcements done, but they were not scheduled based on a technical possibility, but given the economic conditions. So we try to maintain the road to prevent deterioration. We were doing recycling with normal Portland cement that had certain issues with the setting. We proposed the change of binder, but we could not change it because we had international money, international funds, and there were some issues. So we had our experience with this type of binders. Before the tests we have conducted with Raúl and the lab, it was a quite long job. But we had quite good results. And as to the mean time for compacting, I think that the second question, that was the second question. Yeah, it was. In this type of mixes, given my experience, it is essential to do lab tests and simulations, as Raúl said. The open time, that compacting time, where you can be sure that you are going to have a dynamic modulus and the recycled mix, it's a result of tests, because it depends on the type of material you are recycling and on the type of binder you are using. These binders had the possibility of working with more certainty when we have certain delays, such as broken down equipment, climate issues, and we need to do testing, and these have to be associated with economics. Of course, from the technical point of view, they are quite convenient. What about S2? And S2, you know, that has lime, cement, and quinqué, but we really don't know the composition. I must tell you that I do know the composition of S2. In fact,
a demanda, digamos, de.
So if upon request from the customer, we can provide them with the binder. We are working on trying to author the approval of these binders here in Argentina. When we started with the project, it was not approved, but the composition should be declared here in the country. You need to provide the exact composition of the materials, perhaps not the exact or the precise percentages, but yeah, the materials that are part of the binder. Good. Last question for Raúl. It's quite a long question. Is by Engineer Becker. Says, based on what he saw in the presentation, the use of normal cement, Portland cement would enable you to have 40% saving in cement compared to the binder. I think that is related to strength, and the relative drop in strength were done compared to itself, but not considered an absolute value. So the question was, did you try to optimize the cement content, considering all these aspects, strength and the drop in strength and resilience based on the specifications? I think that Edgardo is right. We need to do this analysis to see in a case-by-case basis whether it's convenient to have a specific hydraulic binder or using just the cement we have available in each area and location. I think that each constructing company should do this type of analysis. In this particular case, finally, we ended up using 3.5% binder compared to the dry material at the maximum density. And if it was possible to reduce the content, percentages would be very much reduced in this case. And when we reduced percentages too much, we started having issues with the homogeneity, and strength drops were quite significant. And this was observed with cement and the different binders. In this particular case, it was better for this, from this point of view, to use the binder. But I agree on the fact that this is a technical and economic study that should be conducted in any project to be able to choose the best material for each case. I would like to add that during the execution of the works, we had many problems with reflective cracks because we're working with normal Portland cement, and that's why one of the reasons why we used the binders. And today, micro cracking is quite commonly used to avoid these, to prevent these issues, but at the time they were not taken into account. In the case we presented, we had no problem with reflective cracking. Okay, thank you. I will now make some questions for Jesus. The first question is by Engineer Garcia Terra. And the question is, what's the maximum thickness of the layer that would enable us to get the maximum density specification, and to resort to more than one layer? If you resort to more than one layer, what binding technique would you use? Here the maximum is 35 centimeters because it's the maximum thickness that can be compacted. You can have 2 layers, but never in one layer. The maximum is 35. And there's a roll that is hexagonal. It has certain flat parts, but I didn't see it working. I just saw it in a fair, in a trade exhibition, but I really don't know. It is said to get up to 50 centimeters for compacting, but I'm not sure. In any case, it's 35 centimeters, and if you have 2 layers, there's no issue in extending the upper and lower part. The fact is that you need to have very short time between the 2 layers. And that's what we've done with 45, 50 centimeters, but you need to have a good quality material. It's not any soil. Okay, good. Here, I have a question related to when a road is open to traffic. That will be an open question for the whole panel. Timings or wait times for opening the road to traffic again. And so if we are talking about road hydraulic binders characterized by slower features, what can you say about that? As to roads being open for traffic, I had 2 slides when it says the UNE 47. It's about IPI over 50 to open to traffic. It's immediate burn index. When you have an IBI or an IPI over 50, it's exactly the same without the overlay or the load that you have in the upper part. It should be over 50. Why 50? 50, it's mainly because there were some tests with 65, but for me 50 was valid because we were recycling in the border between Portugal and Spain, and we had to open the road for traffic, and they had no other alternative because we could not deviate the traffic. There were no alternative routes. And so in the last stretch, I did the tests and the essay, and it was 52. So we decided on an IPI of 50, given the use made of the standard together with the French. But in fact, it's at 65. I wanted to add that in our case, we open for traffic immediately with irrigation with emulsion and crushing sand. But there are many international papers saying that you can subject these layers to dynamic effects immediately, and they recover over time. In the case of binders, recovery is a little bit slower, but in our case, we had no issue whatsoever. We opened for traffic immediately, and after we worked on the stretch, there was a heavy rain, and this may bring issues, but in fact, it helped us because it was a immediate moisturizing of the base or wetness of the base, and so we had no ruptures, no breakings. This works with internal working. It is a stabilized base that gets strength over time, but if you have a good, well-designed granulometry structure, it can withstand the traffic. Thank you very much. I think that we have covered all questions, and now we have already run out of our time. So thank you very much, and we close this panel. Thank you, Gustavo, Raúl, and Jesús, for your participation in this seminar, and thanks to all our technicians and all those who are joined here, connected to us. And then we will come back to 11 a.m. Buenos Aires time to continue with the second session. And I invite you to connect to the network and space by choosing your working language. Thank you very much. Thank you, everybody.
Gracias, Diego.
Bueno, bienvenidos nuevamente. Gracias por acompañarnos. Vamos a comenzar la sesión técnica número 2.
Thank you very much for being here with us. We are going to start with session number 2. We have 3 technical lectures, and as we did for the previous session, after the conferences, we're going to open the floor to a Q&A. Those people who want to ask questions can use the Q&A box at the bottom of your screen. Please do not use the chat for the questions. Make sure you use the Q&A box. And we are getting some of the questions from the previous session, and we are going to pass them on to the presenters so that they can send the answers later. For this first conference, we have Engineer Eugénia Correia and Pedro Carvalho, who are going to present cold-in-place recycling with cement EN4. Eugénia is a civil engineer specializing in constructions, and she is the head of the Engineering and Environment Division of Infrastructures in Portugal Sociedad Anónima. Ingeniero Carvalho is an engineer specializing in structures, managing projects, coordinating security and safety in construction of roads in Portugal. Eugénia and Pedro.
Thank you, Diego, for your kind introduction. We are very happy to be here with you. And we would like to give you a presentation about cold-in-place recycling with cement. This is concerning the rehabilitation works in National Road number 4. This case study that Pedro and I will present is the work is the result of a work of Elder Lourenço, Pedro Carvalho, Anabela Martins, and I. And we will focus and we will try to give you the perspective of a road infrastructure manager. It would not be a too technical presentation, but we will focus on technical designs of aspects, construction aspects, and most of all, we will try to explain why going for a circular economy model is a good and wise solution for a road infrastructure manager. So, first of all, let me introduce you our company, Infraestruturas de Portugal. This is a company, a public company that results from the merger between the two Portuguese public institutes, REFER, the National Railway Network, and EP Estradas de Portugal, the National Road Network. This is our country. As you can see, we have a well and spread consolidated national road network. This excludes the municipal roads. Most of this road is under concession, and but there are also some minor kilometers that are concession to another companies. We have a total of 70,708 kilometers length of national road network. So, after decades of investment in the construction of new roads, the challenge is to direct the very scarce financial resources available to the rehabilitation and maintenance of the existing national roads. How do we do that? We have to create strategies of pavement rehabilitation solutions with a view to a better use of available resources, either economically, because the money to rehabilitate roads is not that much, and either of the existing materials, because more and more countries have legislation that oblige to use recycled materials. So one of the best solutions for good technical, economic, and environmentally sustainable management is the use of recycled materials in pavements. So the circular economy model is presented as a production consumption model that promotes the use of resources. One of the key ideas of this model is the idea of a closed loop with zero waste, where materials required for production are almost entirely derived from the recycling materials and not from extraction. So our case is a national road with 25.5 kilometers that we had to rehabilitate. And the recommended strategy for this project was to study solutions with a high rate of reuse of existing materials and at the same time guarantee a lower cost for intervention. In this case study that we will present, the technical, economic, and environmental advantages and disadvantages were evaluated by implementing the in-place recycling solution versus a traditional, I will say so-called traditional solution, which is removing the pavement and constructing a new structure. We will also focus on the importance of laboratory control for the success of the solution. This is the location of the road. We have a cross-section profile type 1/2, a lane of 7 meters wide, shoulders of variable width, 0.5 to 1 meter with or without paving structure. It was possible to divide the extension into sections with different traffic demands. The average annual daily heavy vehicle traffic for opening year were 269 and 527 per each section per direction. We considered the design period of 20 years to compare the solutions, and the existing pavement was a flexible pavement. This is the cross-section profile. So how do we do these cases? We all start by doing a preliminary investigations. This is very important when you go for a recycling solution. So what did we do? We consulted our pavement management system. We conducted a falling weight deflectometry campaign to assess the stiffness deflection. And we conducted an IRI campaign. It was made an extensive visual inspection to detect and classify the existing pathologies. We also conducted some field work where we extracted 23 cores and we executed 13 test pits. The collected material was characterized in laboratory. So for the granular materials and subgrade soil, we did the granulometric analysis, Atterberg consistency limits, sand equivalent, heavy compactation with a modified Proctor. We determined the bearing capacity ratio of the soil. And for the bituminous mixtures extracted, we conducted some bitumen penetration at 25 centigrade tests, bitumen softening temperature by ring and ball method. We determined the maximum technical variety of the bituminous by the pycnometer method. We determined the percentage of bitumen of the various bituminous mixtures, and we also determined the apparent density of the bituminous mixtures and did the granulometric analysis of the aggregate in these mixtures. So what have we concluded? This was a road that was built around 1946, and it had several interventions all over the years until the last one in 2010. The central lane presented bituminous hot mixtures ranging from 5 to 20 centimeters, also cold open bituminous mixtures in an average thickness of 9 centimeters, and some hydraulic macadam. This is a big stone aggregate material ranging from 18 to 30 centimeters. In the winding zones of the lane, because this lane was winding along the year, there is an average thickness of hot bituminous mixtures of 20 centimeters and granular material in crushed aggregate of extensive granulometry and selected soils with 30 centimeters. So, regarding the pathologies, we checked that we had a very severe degradation state where we had mostly cracking, heavy cracking and wheel wane deformation. We had a quality index from poor to bad. As you can see, our scale here is in Portuguese. I do apologize. It was not possible to translate the scale. It was possible to conclude that more than 60% of the extension presented serious pathologies without enough structural capacity for the requests and requiring robust rehabilitation solutions. So that you can see our pavement quality index is a function of longitudinal unevenness, transverse unevenness, and cracking, and our values in more than 60% of the road were below 2.5. This leads us to the need of a structural maintenance. So what did we do as a road infrastructure manager? We have to know how much will this cost us and how much waste will we produce, and what is the more interesting solution for us in terms of complexity, in terms of construction methods. So we have assessed two solutions. One solution of reconstruction a new pavement, and another solution of doing full depth reclamation of the existing materials with the use of an hydraulic binder. Why an hydraulic binder? Because we had a very low structural capacity, we had a very heavy traffic, and materials that we got the results from the preliminary investigations told us that this would be the best solution. So here are the two structures. For a more traditional one, 25 centimeters of bituminous layers and 20 centimeters of extensive grading crushed aggregate, which is a flexible normal pavement. And for the circular economy model was the full depth reclamation of 30 centimeters, and then a binder layer and a wearing course layer with a total of 8 centimeters of bituminous layers. So it was defined as a design criteria what were the parameters that this project should have. So we decided, we defined it with our designer that the cement percentage in relation to the total dry mass of the materials should have a minimum of 30%. The single compressive strength at 7 days would have to be a minimum of 3 megapascals. The simple compressive strength at 28 days would have to be a minimum of 5 megapascals, and the tensile strength at 28 days in a diametrical compression test would have to be a minimum of 0.6 megapascals. Simple compressive strength at 90 days, a minimum of 8.0 megapascals. The tensile strength at 90 days in a dynamic compression test, a minimum would have to be 0.8 megapascals. Also, the question between resistance to simple compression with immersion at 14 days and resistance to single compression at 20 days would have to be equal or greater than 0.75. My colleague Pedro will talk about the values obtained in construction, but they were all higher than those defined in project. So for design, the mixture after compacting should reach a modulus greater than 3,000 megapascals at 28 days and 5,000 megapascals at 90 days, determined in place through load tests with impact deflometer for the first trial section. The design value for us to determine the bearing capacity would have, and to do our calculus, were 5,000 megapascals. So we use the software Bizarre 3.0. This is the stabilized layer expression. And we use for the constant, for the material, we use the 0.07. One of the concerns when recommending mixtures with high rigidity, as the recycled mixture with cement, with the combined effect of the temperature variations and the traffic actions, is the appearance of cracking by thermal retraction. In order to avoid it, we defined in the construction specifications the execution of a transverse pre-cracking. And our binded layer was recommended to have special flexibility characteristics to avoid the propagations of cracks to the wearing course. For that, we used a rough bituminous mixture with rubber modified bitumen. Now I will pass my presentations to Pedro that will explain the constructions and the conclusions of this project.
Thank you, Eugénia. Good morning, everyone. We'll talk about the construction aspects of this works. The recycled equipment was a Wirtgen WR 2500 with a WM 1000 to do the cement water slurry mixer, as equal as we already see this. The recycling depth was about 30 centimeters. In these photos, we can see the equipment and the cross recycled structure. The minimum cement content by mass was 3% and in situ density above 97%. There are some photos of the works. And the recycle layer, and we have to obtain these values. As I already said, Eugénia, minimum compressive strength at 3 megapascal at 7 days, 5 and 8 at 28 and 90 days respectively. So, related to quality control of the recycle layer, some of the aspects related to the execution of the recycle layer are related, namely the working formula, stabilization, working time, and thermal retraction cracking. One of the most worrying aspects was the variability of thickness found in the pavement. The shoulders are very thin, the center was very, very wide, which made it difficult to determine the working formula, requiring in certain areas a previous milling work of bituminous mixtures that were not incorporated into the recycle layer. With this milling, it was possible to create a single formula because we reduced the percentages of the bituminous layers and the hydraulic boundary was more effectively. regarding always the percentage of cement in the formulation of the mixture points to the minimum value defined in the project, the 3%. The trial section was performed on the left road on November 2017, attesting to the formulation of the mixture prepared in the laboratory, and the following data were verified. Simply compressive strength at 7 days in order to 4.1 to 4.8 as well. At 14 days and 28 days, we reached the value stipulated in the project. It was a successful trial section, we can say. In the first phase of production, with the milling we thought it was necessary, and it was, the results were even better. We have obtained in the trial section. These results were reflected in our parameters at 7 days and 14 days. In most situations, resistance gain occurs in the first phase up to 7 days. And at the end, at 14 days and 28 days, the value points to values closer to those stipulated in the project. Regarding the compaction control in the experimental section, final values of 98.1% were obtained, well above of the 97 required in the project. The values obtained are considered ideal for recycled structure because with lower densities, even if with little significance, they can lead to significant reduction in resistance. At the same time, it was necessary to ensure that in the pre-compaction, the values were lower in order to avoid moisture losses and ensure that the bottom of the recycle is compacted. Through the recycling work and due to the heterogeneity of the existing paving structure, there was a need to adjust in certain sections the working formula, but in not a significant way, just an empiric way. As shown previously, quality control through the work points to the following results. The resistance to simple compression on the first day at 7 days, 14, 28, and 90 point values equal or higher than those defined in the project. Tensile strike at 7 days and 40 days in diametric compression tests always presents values higher than those regarded in the design, and the quotient, as we've seen in the table shown by Eugénia, was the main obtained. Finally, it is added that the current time of the recycled layer was quite variable over the several months of work, never reached the theoretical time defined in the project, the 7 day, which required formulations to the planning of the works. The decision, for conclusion, the decision in the design phase to follow a circular economy model is validation after its implementation because in addition to the advantages that are exposed through this case study and presenting all existing documentation on this subject, the need to evaluate the two solutions in design phase is urgent in the economic, environment, and technical aspects, considering the implication of the implementation of the recycling solution. The following table highlights the aspects that are considered most important in the decision making in the design phase. You can see the linear economy solution versus the circular economic solution. Related to costs, the difference is a huge difference, and because of the new bituminous mixture, where is very high. Milling and remotion, we have more quantities in linear economic solution versus the circular economy solution, and of course, the percentage of reused materials in the linear solution is 0, and in the circular economy solution, we have obtained 74% of the reused materials. Related to equipments, construction process, performance, curing time, and quality control, the circular economic solution is more demanding, more complex in construction process, less performance, curing time much more higher, and quality control more demanding. In this graph, we can compare the two solutions, and we can see that the environmental impacts in the linear solution and costs are much more higher than in this model of the circular solution. Concluding, the main aspects considered in the decision-making in the design phase when comparing both solutions conclude that the use of the recycled materials was the most economical rehabilitation solution. presented the environmental advantages, which highlight the use of aged pavement materials, elimination and reduction of waste products to lead to flow and reduction of energy consumption, reduction of emission of harmful gases, have more specific and technical requirements, presented more demanding construction methods than other in a good performance. For conclusion, we can say that the circular economy model is better, but we have to look at the big picture. Sometimes we have to choose the two solutions because of the traffic, because of the cross sections, the more aspects we have to consider when in the design phase. Thank you for your attention.
Thank you, Eugenia and Pedro. Vamos a pasar ahora a la segunda conferencia de...
So now we go into the second part of this panel. And the conference would be the development and evolution of cold in-place recycling with cement in Uruguay. In this presentation, we will have Luis León and Nicolás Vaz. Luis León is a civil engineer with specialization in transport and communication roads. He is part of the National Road Administration of Uruguay, and he works in road project and design. And Nicolás Vaz is also a civil engineer with a specialization in transport and communication. He works as project engineer in the road department, and he's engineer in the construction division from the National Road Administration from Uruguay. So Luis and Nicolás, you have the floor. Thank you for being with us today. Good morning, and thank you very much. Thank you for the invitation to participate in this seminar and to tell you a little bit about the history of cement recycling here in Uruguay, and we will start with our presentation. So, as I was telling you before, this is a small history of how this technique has been developed in Uruguay, and it's a very short story compared to some other countries. The national network, sorry.
¿Ahí lo ven? Gracias. Bueno, como les decías que en Uruguay...
As I was telling you before, we have started with the development of recycling technique a short time ago using cement. The national road network comes from 2015, 2016, when we started working on the cement recycling technique. And this was the result of the acquisition of the first recycling equipment in the market. In Uruguay, the inclusion of the incorporation of this equipment came a little before starting applying the technique, and we tried to gain experience in different activities. Basically, in Uruguay, we can see the national road network is 8,700 kilometers, maintained by the Public Work Ministry. And as you can see there on the map, the recycling technique has been developed and projected for the whole country and all the locations in the country. As you can see, that was a quite quick evolution. We started in 2015 with just a few testing kilometers, and in 2016 the companies proposed to start using the technique, and the Ministry of Transport accepted and approved that. And as from 2017, the Transport Ministry started specifying cement recycling, and we have been able to keep a good number of kilometers given the extension of the country. We have approximately 1,700 kilometers being recycled with cement. And considering what Jesus said in the first presentation, to make a differentiation between recycling, which means using the material you have on the road, or stabilizing, in place stabilizing, something that is being implemented in Uruguay by using recycling equipment. And so it's not easy to make a difference or to differentiate one from the other in the country. But recycling without contribution by the material on the road is approximately 20% of the network. We have already recycled 20% of the network with the cement. So the use of the material on site depends on different factors analyzed during the project stage. So maybe because we need to correct granulometry, or given the specific need to have more structural support. In Uruguay, forestry load and cargo and the serial cargo have increased a lot in our road network, and this has been a great demand on the roads because of the cereals and lumber cargoes. So we have started recycling old roads, different overlays and surfaces, trying to provide a structure that would bear those loads. And this technique has been very well accepted. So this is to show you that all the bases that have been stabilized with cement in the country have been projected with different road layers, where we see asphalt mixture and bituminous mixture, but we have had also some Cape Seal layer, and we have also done in place stabilizing with cement for concrete layers. It is important to point out that all the contracts being managed by the road administration, PPPs, and level of service maintenance and greater maintenance works have incorporated this type of solution, and companies have really accepted this technique, and most construction companies in the country have had some experience with this solution. In 2017, the Ministry of Transport had started specifying and perfecting the description of these specifications, and they have included everything related to those equipment required for recycling. As to recycling equipment, some like strength and power and homogeneity have been specified for the recycling mixture. Uruguayan companies have the Birkin equipment. We also have CAT equipment and some Chinese equipment from China, but most companies have Birkin equipment. And as Jesus said before in his presentation, basically all of them have a 2.4-meter recycling drum, but there are some smaller equipment. Perhaps these equipment have lower power, and perhaps there's some issues when trying to recycle over 25 centimeters thicknesses, but it's okay. Cement, the cement distributor in Uruguay, at least, we do not know whether there's a slurry cement, or we know that it can be done wet, but in Uruguay, all cement is managed to dry. So we have the truck or a trailer that comes with the cement, and all companies use dry cement in Uruguay. These are very good equipment that provide a very homogeneous distribution of cement. And finally, what we have incorporated are automatic leveling equipment. Many companies have started using them, and they have reported on very good performance of this equipment, and they have been very useful to correct certain issues. And they have been incorporated this type of equipment for recycling, and they have had very good results. So now I will give the floor to Luis to continue. So Nicolás was commenting about the different specification of the different equipment, and I'm going to talk about material specifications and as regards the use of the technique. As Nicolás said, the first tests were done in 2017, and this is a technique that was not used before in Uruguay, so we try to look for specification from different countries that had more experience with this technique, and so unconfined strengths at 7th day between 20 to 30 kilograms, and to prevent cracking that would come later because of the contraction of cement. On-site or in-place density over 98% according to the modified product, and minimum of 3% of Portland cement, of course. There's a formula where we have different test tubes put in the different proportions of the materials to be recycled. And as from there, we defined the amount of, or the quantity of cement to be included in the mixture. After that, we started using transversal laps of at least 0.15 meters, 2 meters between days, and profiling and compacting jobs should not be done over 2 or 2.5 hours. Some requests for proposals stated 2, or some others 2.5 hours, and then we included curing. At the beginning, we were not certain whether we should open for traffic immediately or not in this type of basis. And clearly, it is very difficult not to have the road closed for a long time, because in general, roads here are two carriageway roads, so you need to be open for traffic as soon as possible. But what it was requested at the beginning is that the recycling equipment would not be away from pavement, but then since there were some issues about some detachments caused by traffic, what we included was a curing through reinforced priming with emulsion and crush dust. And after that, we could open the road for traffic with no issues whatsoever. Some requests for proposals included the LWD, what has been specified as micro cracking to check for crackings, and after the passes that's in the test stretch, it is 100 or 200 meters. We tested with LWD before and after, and it should not be over 30%. We did some tests also with LWD. So we were implemented this, and we were able to get modulus gain curve that is quite interesting for recycling. And then on the other hand, we're also doing a checkup of all the structures with the FWD. We do this consistently, and we do some annual measurements. And to anti-reflective cracking, what we use in Uruguay, it's micro cracking with a plain vibrating roll of 12 tons at the maximum frequency and minimum amplitude. In the test stretch, we determine the number of passes we need to have, and the technique should be executed after 24 to 48 hours of spreading the layer. And you can see there on the picture what can be seen after the passes. On the other hand, also we have a company that has proposed a variation to this technique and started working on the transverse joints. And what they do is a cut up every 3 to 4 meters, and they inject emulsion in those cuts before profiling. We are going to show you a video of how the company does this cut. This equipment has been modified and manufactured by the company with a drum that has emulsion inside, and they have kind of a blade that you can see there that comes into 2/3 of the depth or the thickness of the layer. This technique has been well accepted and has had good performance. Also, we have started using the nuclear densimeter that is calibrated through the sand cone by using the sand cone test, but it's not yet specified by the ministry. Some of them have been used. And so Uruguay's experience with the recycling has been very good, of course. We have had contraction cracks and cracking, but in general they have been controlled. And at the beginning they are not sealed because of the aspect, the look and feel of a new work, but if they are important, they are sealed. And we also apply the hard shoulder recycling. So this is used with a milling machine, 15 centimeter thickness. Currently we have 70 kilometers of hard shoulder recycling with a very good experience, and there are 110 kilometers that are going to be soon recycled. We do mechanical cement laying, or we can use this. We can see what is a hopper that has been just put into the machine to be able to lay the required amount of cement, and this can be regulated. With that, we can lay, we have some overlays with low thickness, and in the hard shoulders there may be some defects. With this recycling technique, we can have a good contribution to the shoulder, and we can do the job in 3, 4, or 5 centimeters. Here we have a video of how this technique is used. So as Nicolás was saying, you can see in blue the recycling jobs that have already been finished. In red, what is going to be done during 2021. In green, you can see some stretches where the shoulders are going to be recycled also. Thank you very much. Thank you for your attention, and thank you for the invitation to make a presentation in this seminar. And I would like to thank also all the companies for the material they have contributed to us, and also the information they have provided us with. Thank you very much. Thank you, Luis and Nicolás and Luis. And now we are going to go to the last presentation in this session. And the title is Recycling Practices for Airport Pavement Construction. And the presenter is going to be engineer Emanuele Toraldo. Emanuele is associate professor of road, airport, and railroad constructions in Milano, Italy. He is also a scientist in the Transport Infrastructure Lab in the same university.
For your contribution to this seminar, you may start your presentation.
Thank you very much for your invitation. It's a pleasure for me to be here. And I'm going to talk about a particular use of the recycling practice. In particular, I'm going to show you a couple of case studies regarding the airport pavement construction, airport pavement rehabilitation. These two rehabilitations were carried out on taxiways at the Malpensa airport in Milan, in Italy. And the airport of Milan, Malpensa Milan, is an hub, an Italian hub, and it managed more or less 18 million of passengers per year. The rehabilitation case studies I'm going to show you are related to the rehabilitation, two different approaches and different taxiways, as you can see in the picture. Regarding the first case studies, it was the rehabilitation of taxiways A, B, AA, BB, C, and M in front of the Terminal 2 of the Malpensa Airport. The taxiway was made of 50 years old pavements made of 2 layers, a concrete slab and a cement-bound sub-base layer. And during the during the life of the pavement, some spot surface maintenance interventions were performed through a partial milling of the slabs and asphalt filling of 4 or 5 centimeters. As you can see in the pictures, there were a lot of distress on the pavements, and for safety reasons, the rehabilitation was strongly needed. The idea of the rehabilitation is to study the real pavement distresses on the taxiways and to define if it's possible to a rehabilitation strategy related to the conditions of the pavement. This was the first important part of the project, because in the first part, the preliminary investigation allowed us to define 2 different areas in the taxiways. The first one, the red in the picture, in which pavement deterioration involved both concrete slabs and cement-treated sub-base layers. So all the entire pavement was distressed. The second one, the second area in yellow in the picture, in which the concrete slabs were at the end of their life, but the cement-treated sub-base was in good condition and so was not removed. A lot of preliminary investigations, a lot of tests on site and on materials takes from pits on the taxiways allowed to define these two different scenarios. These tests, of course, are very important when you want to recycle materials in your infrastructure. Particularly, is the infrastructure is an airport infrastructure. So the existing layers were tested point by point, layer by layer, and then the materials that were coming from the layers that will have to be removed were used as aggregates, as recycled aggregates for the new pavement. So the design was to define a pavement one for the area one, the red graph in the picture, and a pavement two for the area two. Regarding the first area, we performed 88 centimeters thick of new pavement.
Sí. Bueno, sí, cómo no. Bueno, tenemos algunos problemas técnicos.
I'm sorry, we have some technical problems in Emanuele's source sound stream. So we're going to try and reconnect as soon as possible. We're going to give him a couple of minutes. And if not, we are going to move on to the questions while Emanuele is not with us. And when he can, he will reconnect. So I think we have to move on to the Q&A now to take better, to make better use of our time. Eugénia and Pedro.
Because Emanuele is having some problems, we're going to advance with some questions that we received for the first conference, if you are okay. The first one question I have for you, Eugénia, is this. It's from Christian Spandre, and he asks you if you observed in the project any deformation in the asphalt layer, since he heard that it had a content of 5% of asphalt, and he considers it a bit high. Did you have any issue about deformation in the asphalt layer after the rehabilitation?
No, we haven't seen any deformation in our asphalt layers. This was constructed in 2017, early 2018, and so far we have not seen any deformations. Was this the question?
Yes, yes. The second question is about if you can, during the project, if you were able to verify the elastic modulus in the field, and if you compare it with the previously expected in the design. And
se o módulo, se nós conseguimos verificar o módulo. Conseguimos verificar, sim, o módulo dos 5.000 megapascais que nós obtivemos no processo de aliança. Yes, we could check the modulus with the deflectometer, the load tests, and we reached the design models. I don't have it here, the values, but we were able to reach the design values.
Okay, well, thank you. I have two questions for Nicolás and León. León, tengo unas preguntas para usted.
I have two questions for Nicolás and León. The question from Fabian Schwarzer is, what result did you get from the use of LWD on cemented layers? Because he understands that specifications indicate that this equipment should not be used for this type of layer. Well, we were saying that in some cases those were the specifications, but given the variability of the results, we stopped. And we conducted some work, as we said in the presentation. Depending on the age, we started at 2 hours, 14 hours, 2 days, 7 days, and 28 days, testing these layers. And in fact, we were able to obtain deflection without problems. And the gain of the modulus was clear, and we did it for two different tensile values, one of 465 megapascals, that's the small slabs, and so it's a little bit different if you use percussion, but we did not have problems. There were no issues, and we could see how the modulus was progressing as the days went by. It's not something that is specified nowadays, and it's not used nowadays in the specifications, exactly given the variability of the results, which did not make it as clear whether we could use LWD as control. One more question. Ana Sofía Figueroa from Colombia is asking you about the pre-cracking method through joint management. Once the process that you showed in the video is done, how do you deal with that until the finishing stage? Well, after that video that we showed, there's pre-compacting of the material, and then after that we use a compacting machine and we do profiling of the material. And of course, if we think about the equipment used, it's a goat leg type of equipment with a machine leveling and an automatic roller to seal it. And then we do priming, which is what Luis mentioned. We do reinforced priming with an emulsion and crushing dust or crushing sand, and some companies use gravel, small gravel, which has given them very good results. and that stretch can be open to traffic. As Luis said, in Uruguay we have a difficulty because it's a two-way street normally. Here, Armando Galindo Dominguez is asking about how you do the follow-up for the results of LWD and FWD. As I said in the previous question, with LWD, we did that follow-up, and with FWD, the idea is to have or to check those two stages in cement recycling, where you may have slabs that are more rigid and then it starts behaving as granular material. That is what we are doing. We are doing percussion tests throughout the year, and the reaction is more or less the same as after 28 days of recycling. And we are going to do the 2-year campaign in order to check whether there was progress. And we know the pavement layers. We did this in one of the stretches without overload, which was 100% recycling material. And after we process those deflections, we may be able to see what was the progress made in that year. There's a lot of traffic, lot of lumber cargoes, so we will be able to quantify how this cementing has behaved. But in 1 year, there was practically zero progression in deflections.
Thank you very much. We have a last question before giving the floor to Emanuele from Agustin Martinez. The question is whether does the specification of including micro-cracking in the technique used in asphalt treatment, or do you just include micro-cracking where you lay asphalt concrete layer? We have specified that basically in the 3 types of flexible surfaces, because I told you that we have had experience with the Cape seal also, and we have specified micro-cracking. As Luis said, there are some cases where the micro-cracks can be just seen better, as we saw in the picture in the presentation, but in some other cases, after some passes of the plain flat roll, there's no difference to be seen. And if you saw the pictures of the LWD, we were able to control to whether there has been a fall or not, and we had certain variability there. That's why we no longer specify it. And we have done that over the last year, so thank you very much. And I have more questions, but not to use up our whole time for the panel, we will once again give the floor to Emanuele.
I think so, I hope.
Okay, well.
Can you hear me, yeah?
Yes, can you share your presentation?
Yes, of course. Can you see it?
Yes. Whenever you want, you may continue.
I'm very sorry. As I was saying before, we are talking about 2 rehabilitation activities carried out at Malpensa Airport in Milan, one of the 2 hubs in Italy. The first one is related to the taxiways that give the possibility to aircraft to go to the apron in front of the Terminal 2 of the airport. The rehabilitation was needed because the 50 years old concrete slabs had a lot of distresses, as you can see in the pictures, and and these slabs were on a cement-bound subbase layer. The idea was to carry out a preliminary investigation in order to understand the current situation of each layer, the current bearing capacity of each layer, and then to decide the design of the pavement. As a result of this preliminary investigation was that we identified two different areas, 1 and 2. The first one in which both slabs and the cement-treated subbase layer were affected of a lot of distresses, and the second one, the yellow area, area 2, in which just the concrete slabs were at their end of life. So the cement-treated subbase layer was in good conditions and not milled. These are the list of, in this table you have the results we found checking the preliminary investigation by both on-site and laboratory tests. It was very important to understand the conditions of each layer composing the old pavement, and the point was that we were able, by using the information deriving from the preliminary investigation, to design two different kinds of pavements, and the two pavements were different because the pavement one of area 1, in which both the concrete slabs and subbase were removed, we used crushed the millet material. We reused as aggregates for the new layers, in particular for recycling the cement-treated subbase layer. Also, a cement stabilization of the existing soil was carried out. The upper layer of this pavement was made of two different layers, an intermediate asphalt layer and a surface layer made of open grade filled with cement mortar, and I'm going to discuss it later. As regarding the pavement 2, 29 centimeters of the existing pavement were removed, so the slabs, and it was and the rehabilitation was recycled cement and bituminous emulsion treated material, reinforced by fibers, and the aggregates for this layer were obtained by milling, crushing, and selecting the old concrete slabs, and two surface layer, and a surface layer, and intermediate layer made of bituminous mixture. These are some results of the key materials used for the reconstruction, and these are also the results we obtained in the during the mixed design of the different layers for pavement 1 and pavement 2. For comparative purposes, the two solutions were compared from an environmental point of view with a standard pavement used in Italy for taxiways of airports. The idea was to understand what is the environmental effect on deriving from the use of this kind of techniques. So, as a conclusion of this survey, of this analysis, environmental analysis, a total amount of 46,000 cubic meters of virgin aggregates were saved. And in terms of CO2 equivalent emissions, 29% and 65% for pavement 2 and for pavement 1 and pavement 2 respectively were saved by using this kind of techniques. So you have a huge amount of environmental saving and also cost saving by using this kind of techniques. The second rehabilitation case study is regarding the taxiway WA. It was necessary because the airport had to change its infrastructure for the new large body aircraft such as Airbus 380. And also in this case, the idea was to recycle the old concrete slab as a new material for constructing the new layer. In this case, a total of 76 centimeters of pavement was rebuilt. And in this case, the sub-base layer and the cement-bound base, so 70 centimeters in total was reconstructed by using as aggregate the old concrete slabs. So we reused in the same place the materials we removed from the old pavement. Regarding the sub-base layer, going very fast, the old concrete slabs were milled, sieved, and selected in order to mix this recycled material with the in-situ material. And we had a lot of tests by using a test track in which we defined the type and content of hydraulic binder we have to use for optimizing the performance of this kind of layers. And at the end of the analysis, the mixture containing 3.5% of cement showed the best bearing performance and curing speed of the layer. This is just the activities we had during the test track and also during the phase of construction. Regarding the upper layer, the cement-bound base, the aggregate once again were obtained by the crushing and milling of the crushing and sieving of the old concrete slabs, and there were also use of fibers as a reinforcement of this layer. As you can see in the pictures, we did a number of laboratory tests related to compaction, volumetric, mechanical, and failure resistance of the materials. And on the right of the slide, you can see the effect of the fibers regarding the ITS test, and the result of a spacement in which the fibers are used or not. As you can see, when we not use the fibers with the same kind of materials, we had a complete separation of the spacement during the test. So the 4% of cement and 8% water was selected, and the use of fiber were the materials used for this layer. Regarding the upper layer, it was an open-grade bituminous mixture filled with cement mortar. It is a quite new solution, in particularly when you use it for airport activities. The idea is to use a porous asphalt with a 20% of voids, and to fill it by using a cement mortar. The idea is to combine the effects, the quality of the two different materials. In this view, a lot of tests and regarding the mix design and the curing effect and the laying and applying activities were performed before using it to build the new taxiway. And in this view, it was very important, a special focus on the workability of the mortar to penetrate into the porous asphalt, as you can see in the graph on the right. This is the viscosity of the mortar in related to the time. As you can see, when you change the environmental temperature passing through 60 degrees to 20 Celsius degrees, you increase the workability time. So you have more time to allow to the mortar to penetrate into the porous asphalt. Once again, also regarding this kind of rehabilitation, we try to understand the environmental impact of this solution related to a standard solution for this kind of activities in Italy. And the result was that an environmental saving of 35% in terms of CO2 equivalents was estimated. And in the pictures, you can see some information about the working area at the end of the job. I'm going to finish my presentation, remembering you that in the next September 2022, we are hosting, we have the pleasure to hosting in Milan the 9th Symposium on Pavement Surface Characteristics. If you need some more details, you can visit the surf2022.org or write me an email, and the abstract submission is still open, and we are more than welcome, more than happy to welcome in Milan next September. Thank you very much, and I'm sorry for that happening.
Thank you.
Thank you. I hope now it was okay.
Yes, it was okay. Vamos a comenzar ahora
Let's start now with the Q&A session. I'm going to continue with some questions that came for the first two presentations, and then for sure we will be receiving more questions for the last presentation by Emanuele. So first, we have a question for Eugénia.
What performance parameters do you use to establish the cement dose? Are you hearing us?
Can you please
repeat?
Repeat it, yes.
Yeah. What performance parameters do you use to establish the cement dose?
We use our national contract specifications that set up some values, and then in the design level, we ask for determined values, as I showed in my presentation, to be complied. And so when the mixed design was done, if those values were not complied, the layer would not be accepted. So does this answer your question? I can show you those values again if you want in the presentation.
But is there any approximation related to durability of the mixture? I mean,
is there?
Regarding resistance to wetting and
I apologize, I don't understand.
If you address in the mixed design durability issues like freezing and thawing cycles or wetting and drying cycles?
No.
Okay. And I have another question. Is about the cracking control with the pre-cracking. You show us. You indicated in your presentation that you made transversal joints in the layer. I wanted to ask you at what distance do you make these joints, and if you practice longitudinal joints.
We made some joints in 30 meters, but the the principal aspect of the cracking control was the bituminous layer with rubber that we could have located above the recycled layer, and we have some time without have the conditions to put that layer because it was a lot of raining, and the cracking did not appear. We have some time if the cracks appear because we couldn't locate the rubber layer immediately by meteorological conditions. And when we were able to put that layer, there were no signs of cracking. It was a very good situation that we can assure.
Okay, thank you. Nicolás, tengo un par de preguntas para ustedes.
Nicolás, I have a couple of questions for you. One is related to the type of cement you used. Can you give us some details? Did you use composite Portland cement? Not. The only cement available in Uruguay is normal Portland cement, which is quite similar to the cement in Argentina. And we have not used any other type of hydraulic binder. If there's any different experience, would be improvement of the subgrade with lime, but in this type of recycling, the one we presented is just normal Portland cement.
Next question for you is, have you compared the effect on the modulus in stretches where you applied microcracking and versus the ones where you didn't apply microcracking? We know that normally with microcracking the module goes down and then it bounces back, but we wanted to know what's the result if you didn't apply it. Well, the answer is no, actually, because when we use the LWD, when we did it for one stretch, we measured before, but we did not generate historical data for those points. We just made a note, passed, and then we measured again to see how much the modulus would sink, but there was no follow-up or tracking of applying micro cracking versus not applying it. We did apply the technique in one of the modulus, and we have the data for that, but we did not compare with other modulus where we did not apply macro cracking. So for each of the works, we did testing for that site, but we did not generate comparison or historical data.
The first one is you showed in your presentations some savings based on carbon footprints, but the question is, what about the savings, the economic savings?
The economic savings were on the owner of the airport, but of course there were. I'm not able to quantify it because it was of the owner of the airport. However, you have to think that in this case, these two case studies, both the plants for producing the recycled materials were directly on their working area. So there were no trucks, there were no fuel consuming, and there were a lot of advantages from an economical point of view.
Okay, well, thank you. And the other one is regarding the technique carried out in E, W, Y, A, and W.
Yeah.
Similar tasks have been carried out on tracks. And what was the result in terms to coefficient of friction?
So it was okay, of course, because as you know, there are a lot of tests made of the airport authority before opening a taxiway or a runway to the aircraft traffic. So the final result was okay. However, the main problem related to this technique is that when you fill the open grade bituminous mixture with the cement mortar, you have a residual part of the cement mortar on the surface of the layer. That's the reason why in certain cases you have to remove it by different techniques. Because you are in the airport, what we did was to measure the I don't know, the sand and patch method instead of the British pendulum number to identify the surface characteristic of the pavement, and removing when it was not okay. We removed the surface of the one millimeter surface of the pavement, just for emerging the texture of the aggregates.
Okay, thank you. Tengo una pregunta más para los colegas de Uruguay. No sé si van a poder responder, porque bueno, no.
There's another question for the colleagues from Uruguay. I don't know what your regulations are, but what type of compacting do you use? Do you use type 4 with a small mold or 5 with a big mold? And is maximum size more than 3/4 to compensate, or can you use all the material with the mold? Well, this is quite controversial in Uruguay. And in certain works, we use the technique of compacting in a small mold. But lately, we are following Spain regulation in PG3 regarding cement grade, using the big molds to be able to use the whole material for 3/4. This is what we are doing lately, but there's controversy, as I said, and we hope we can arrive to a conclusion. But the thing is that we don't have a long history in Uruguay about recycling, so at this point we cannot tell how is it going to evolve in the future. But this is what we are doing now. Of course, this is a point that we need to analyze and we need to study, and it requires a little bit more analysis to have to come to a conclusion on how to deal with those cores. I have a question for all the presenters.
For all presenters. First, I'm gonna read it in English, and then I will make the translation for our colleagues in Uruguay. When recycling of existing layer is applied, we normally do not physically reach the subgrade. We won't even see it. How do you evaluate the bearing capacity of the subgrade in your country? Do you have any requirements for minimum values? I don't know who wants to start. Emanuele.
Yeah, in my country it depends on the design. So there is the rule in which you can accept the bearing capacity of the subgrade is defined by the design. Normally, we use a static load plate test, and for the subgrade we are asking something like 50 megapascal, 50 megapascal. Of course, it is very difficult to measure it because when you are recycling in place, you don't know really when stop a layer and start another layer. So it is the design that defines the thickness, and then you, during the construction, you have to improve the minimum, the sort of minimum thickness you have from design to increase the bearing capacity of the wall layer, include the subgrade and the recycled layer.
Thank you. Eugénia, any comment? Do you want me to repeat the question?
Okay, so how do we do it here in our country? We assess the bearing capacity usually with the falling weight deflectometer prior to do the recycling, and we know the bearing capacity of the subgrade. So depending on that value, we define the capacity and the depth of the layer to be recycled. And then we use some models, some design models to see what does the best behavior. And of course, then in the construction, we, as Professor Emanuele Toraldo said, we do an assessment and check if we are to correct some issue of the recycled layer and if the bearing capacity is being obtained. I'm not sure if I responded to what was the question, but I think so.
Yes, thank you. Nicolás, Luis, ¿quieren que le haga la pregunta?
Nicolás y Luis, do you want me to repeat the question in English? Well, you're asking what assessment do we conduct on the subbase for structural capacity? Yes, they are asking how you evaluate the bearing capacity. I think we are in line with what Eugénia answered. We do designs conducting effect tests and measurements, and we evaluate the bearing capacity of the subbase, and we do CVR and testing, but there's no minimum capacity that is a requirement. In general, there are no subbase substitutions unless you are building something new, especially when you are recycling. In some areas, you may need more structure because the subbase is compromised, but there's no minimum structural capacity for or bearing capacity for the subbase. And we do testing and measurements to know the capacity, and then we do testing and sampling with CVR. The experience in Uruguay, to complete this answer, is that when you do recycling, you need to have certain characteristics in the subbase with certain features and with a certain thickness, which should be minimum 20 centimeters in our experience. And something that for us from the side of the project seems adequate if you take a look at the modular ratio between the subbase and the recycled layer. That's the experience that we have. Thank you very much. And with this, we're coming to the end of our first day.
Your contribution, for sharing with us your experience. We are closing this part of the seminar, the day one. So I'm going to say it in Spanish. Bueno, muchas gracias a todos los que se han conectado.
Thank you very much for everybody who connected today, and we invite you to connect again tomorrow for the second day of our seminar. We are going to be starting at 9 a.m. Buenos Aires local time. Thank you very much and have a good day. Muchas gracias a todos.